Guys, my name is Ken Berry, and today I'll be working with my partners, Jaden Martinez and Michael. I'll be working on classifying triangles and angle relationships. To start off, we're going to be working on the equilateral triangle. So you're wondering, how are we doing the equilateral triangle exactly? So basically, it's all the same three numbers. So for example, 60, 60 again, and another 6. Now I'll try another one. 70. Let's start building. And 70. Now, if you're ever doing an IXL on this, the easiest thing to do when you're confused on this is this. If they're all equal, that will be an equilateral triangle. Now, for the next one, we're gonna be doing scaling equals. Okay, let's do another example. We'll make it a little bit more simplified. So first we would do 2x. Next one will be x plus 2. And for the third one, we will have x 2. Now, what would the answer be? Right, it would be 2. The reason it would be 2 is because 2 is the only number that can fit all of these inside. It can't go over or under. So the next one I will be doing is called a scale-lean triangle. Now, for example, a scale-lean triangle is three different sides, but three different numbers. So this is different because this is 1, 2, and 3. Is not equal at all. It's not like equilateral. Another example with numbers: 180, 91, and 62. Unlike equilateral, these all have three different numbers. I'll try another example. 145, 61, and 78. Now we're going to try an example, but I'm not going to give the answer until 10 seconds. So the question is equilateral or scale-lean? 5, 4, 3, 2, 1. Guessed it, it was scale. Now for the last example, we're going to be using the isosceles triangle. The isosceles triangle is a side that has two one and one different side. For example, 10, 10, and 15. Another example would be 15, 15, and 10. So in short summary, isosceles triangle has two of the same sides and one odd one out. So obviously for this side, 15 is odd one out, and 10 are equal, and 10 is odd one out for this side, and 15 is equal. Now, we're gonna do a little quiz to make sure you guys are paying attention. Questions are, which one is the equilateral? Which one is an isosceles and which one is a scalene? Yeah, 20 seconds. That's 20 seconds, but you should know it. So this, obviously, isosceles. This one, equilateral. And for last one, obviously, a scalene.
For our next unit, we're going to be working on angle relationships and triangles. So basically, angle relationships and triangles is the sum of all three interior angles, which is always 180 degrees. For example, let's consider a triangle where it's x, y, z. Now x can be 50 degrees, and y can be 70. And z can be 60. So for an example, in the angle relationships and triangles, side xy will be opposite angle z, and therefore will be longer than sides xz and yz. Side xz will be opposite angle y, and therefore will be shorter than sides xy and yz. Now for the last one, side yz will be opposite angle x, and therefore will be shorter, therefore will be shorter than sides xy and x. Example in triangle form, I'm going to make a triangle. Triangle has three sides, so for example, we can use this as triangle angle A, angle B, and angle C. Now, since this is 60, 60, and 60, A plus C equals 180. This is because A, B, and C all add up to 60, which 60 times 3 is 180. That are going to be adding a new letter. The new letter we're going to be using is D. Now, the reason why I add this letter is because we have to make a new triangle out of this since D plus D equals 100. I'm going to explain why. So first, we should make a triangle out of this to equal 180. First, it will be 60, then it would be 70, then this would be 50. But this is a line with no triangle, so where would this go? We will have to make a whole new one out of this and make it 130. And 130 plus 50 equals 180. Now, for the next step, we're going to be doing the same thing we did here. So now we're going to add the letter, let's go with E. Now, since 60 say 60 and 50 and 70 are make 180, and 50 and 130 make 180, we would have to add what equals up to 180 with 60, which would be 120. So therefore, B plus C equals F and A plus E equals 180. We have 120 and 60, which is A and E, and 50 and 130, which is C and D. Now, what would be for B exactly? Now, do the same thing as we did everything else. Make a circle out of it, wherever do we want to do. Now, we have to find what angle B will be with. So 70 plus 110 could be F. So now we have all bars figured out. It can be A plus C equals G. And also B plus F equals 180.
I'm Michael Holland, and today I'm working on SSS, SAS, ASA, and AAS. They're ways to determine a congruent triangle. So, we put that up on the board. So, first off, let's start with SSS. That would mean that all three sides are equal. Now, let's say that another triangle had the same sides with the same lengths, they'd be congruent triangles. They'd have all the same sides. For a little example, I'm going to say 2x, x plus 2, and x squared. On this triangle, I'm going to put x squared, 2x, x plus 2. Now, if you solve the first triangle, this one, you'll know that it's 2. 2 times 2, 4, 2 plus 2, 4. Square root of 2 is 4. Sorry, 2 squared is 4. And then you can use that, and then knowing that this is also an SSS triangle, the same distances to know that this is also 2. The next one I'm going to be doing is SAS. So let me get a shape up in here. And a line down the middle. So SAS would be, say, this side, this angle, and this side. So also, then this side would be. If you were using a proof sheet, which we will have, you would label this one as 1, this angle, and this as 2. It would save you a lot of space, but let's just go A, B, C, and D. There are 2 ways you can write it on a proof sheet. Let's just say this is our proof sheet right here. Let's say this is like a proof sheet right here. I would put down angle 1 is equal to angle 2. And for that, I can use, it be on a given. So you put down like given. But the main reason why we learn all of these 4 right here is so that in the proof sheet we can say triangle ABD is equal to triangle BCD. And you would put down SAS. The next one I'll be doing is ASA. ASA, let me draw the same shape. I shouldn't have erased it. Sorry. ASA would be this, like this angle right here. Let's put this as 1 and 2. Then this would be equal. And then these two angles, we put them as 3 and 4. Now let's do A, B, C, D. Now, instead of doing angle A, B, and D is equal to angle TBC, you can just put down angle 1 is equal to angle 2. So on a proof sheet, you could just write, angle 1 is congruent to angle 2, likely given, well, it is given here. But with using that, you can instantly make the triangle as as a congruent triangle, like both of them they're equal just through SAS instantly. The next one I'll be going over is AAS. AAS would be same shape again. Line down the middle. AAS would be this angle. Let's put this as A, B, C, D. So angle A and then angle C are equal. But then angle B 1, and then angle B 2 are equal, and then BD is equal. And instantly off that, boom, it's AAS. So then so based off that, you should know that these two are congruent, and you can put that down on a proof sheet. The last one I'll be going over is hypotenuse leg. Now, let me just draw a triangle real quick. It's a different triangle this time, I swear. So here's the triangle right here. The boxes are to symbolize a 90-degree angle, right angle. So then let's put this A, B, C, D. Now right off the bat, we know that B1 and B2 are congruent. And then based off that, we would see that if DC and AD were congruent, then both the triangles would be congruent. On a proof sheet, it would look like given is AD equals DC. 1 angle 1 is equal to angle 2. And that's all you need on a right triangle to find out that it is congruent. So that's on a proof sheet. You need to know like which triangle is which, like so that if you come across a scenario where all three of the angles, you immediately know that's the equal triangle, so that you can find out through if like other parts of it, so you can find out the other distances. And let's just like we put it down on a proof sheet as SSS, SAS, ASA, AAS, or hypotenuse leg. That's all I have. Thank you.
Hi, I'm Jaden Martinez. I'm going to be talking about two things today. I'm going to be talking about isosceles triangle, equilateral triangles, and I'm going to talk about CPCTC. CPTCC stands for corresponding parts of congruent triangles are congruent. And I have some examples here for you that I've done, and I'm going to explain them so you guys know the process and how to solve these type of triangles. So right here I have a triangle on the bottom. And what I did was, for number one, it says DC is parallel to AB. So angles DC and angles AB are given. And two, angle 2 equals angle 4. That's their alternate exterior, so that's on the outside. And then 3 says DB equals DB, and that means they're effective. That means they're the same side. 4, angle 1 equals angle 6, and that's given to us. And 5, triangle equals triangle is AAS. And then number 6 is where CTCP comes in. Angle 3 equals angle 5, and that's how we know. Hi, I'm going to be explaining what CPCTC is. CPCTC is corresponding parts of congruent triangles are congruent. If you have so for me to break this down and explain it to you, if you have two things that are the same, every part of those two parts must be the same. And I'm going to give you an example. So if you have two triangles here and you're saying the given is ABC is congruent to DEF, you have to prove that. So as you can see here, angle C is congruent to angle F. And for you to know that, you can see that angle A has one dash mark and angle B has two dash marks. And when you look at the other triangle, you see that D has one slash mark and E has two slash marks. So that means angle C is congruent to angle F because they have no dash marks. And then you can go on and say angle A is congruent to angle D. Like I said for the first one, you could tell that angle A and angle D are congruent because of the dash marks that they have. And then you can assume for the rest. Angle B is congruent to angle E. And you can see that you can see that because angle B has two dash marks like I said earlier, and angle E has two dash marks like I said earlier. So if they're the exact same, you can prove that they're both congruent, and that's how you know, and that's how you use CPCTC to solve that and to give better reasoning on how you can prove if two triangles are congruent. To continue, we were not done. So we have to find the corresponding parts in the angles. So right here we see BC and EF. So we already know that angle C is equal to angle F, and we know that angle B is equal to angle E. So now we can say angle BC is congruent to angle EF. And we know that because both of the angles, the singular angles, are already equal to each other. And then we just go from there. So then we know A is equal to angle D. So we do angle AC is congruent to angle DF. And we know that because, like I said, we already know these angles equal to the singular angles on this side. So we put them together, and that whole angle equals that other angle on the other side. They're reflexive. And now we can do angle AB is congruent to DE. Like I said, we know that because we know that angle A is congruent to angle D, and we know that angle B is congruent to angle E. And then we also can see this in the way it's set up. So I'll write it bigger. So B, C is congruent to D, E, F. It's a very certain order it's in. So we see A and C, like we did here, A and C. And then how the A and C are, we see D and F, and they're congruent. So you can follow the way the given question is giving it to you. So then we see B, C, and then we see E and F. It's just like a pattern. You just have to follow a pattern. And then we also see for our last one, A and B in the front, A and B, and then D and E. So they're all corresponding angles, and that's how I just proved it to you. Thank you. Hi. Okay. So I'm gonna give you guys an example problem so you guys can learn how to do it. So number one. So what we have here, we have two triangles. We have one triangle we have ACT, and then another triangle we have HOG, and we're trying to find H. So we know that angle A is 15. Angle A is 15. You can see that. So, like we said, if two or more triangles are congruent, then their corresponding angles and sides are congruent as well. So if we know this is 15, then we obviously know that H is 15. So that means H would equal 15. I'm going to give you guys another example. Okay, so we have another triangle here. So we're trying to find G. G is right here on this triangle right here. So we know that A is 26. A is 26. So that they're both on the same side and they're both equal. So we know that G would equal 26. G equals 26. Hi, now we're going to be talking about triangles. We're going to be talking about equilateral triangles and isosceles triangles. So one thing to know about equilateral triangles is that all three sides are always equal. So I'm going to give you an example. We're going to come back to solve these later to see if you guys are paying attention. So example 1, we see that all three sides are all 60. So that means it will be equilateral triangle. That's something to remember. Now for isosceles triangle. Isosceles triangle, there's always two sides that are congruent. They're the same number. The opposite sides are always congruent. So I can give you guys another example. If one side is 40, then automatically the other side is 40 because opposite sides are always congruent. Okay, now let's see if you guys are paying attention. If there's three sides that are all equal, what type of triangle is it? Good. If you said equilateral triangle, then you are right. Now we're going to go to the other example. Now, if one side is 40, then what is the other side? And what type of triangle is it? If you said isosceles triangles, then you're correct. You know why you're correct? Because opposite sides are always congruent. That's one thing you have to remember.